Let's get a full screen. So I'm going to call this a classic application. And it's going to be straight line motion. And the goal is to be able to find when this marker hits the ground, given some minimum data, and 10 seconds or less. So I got a marker, it's 40 inches high. I throw it up to 75 inches. I'm going to randomly pick a time. We'll say 0.12 seconds. All right, and so it's going to follow the trajectory of time elapsed. So I started here at 0:40, kind of an initial condition. After point, I forgot what I said, 1, 2, I think I said 0.12 seconds. It's going to reach its maximum height of 75 inches. And I'm hoping that by the end of this video, some folks will be able to tell me that time just writing the answer. All right, so let's have at it. A little preliminary work for folks who have not been immersed in the quadratic playlist. It does take time to learn this stuff. Equation of a line. So we'll start with x minus 5 plus 7. Change of x 4, change of y 23. So there's my linear function. Over here, you can compare it to the quadratic, 2316, x minus 5 squared. Plus 7. Okay, so that's that equation. Notice 16 is actually coming from dropping 9 minus 5. Students say it changes by 4, but it really changes by 16. We didn't want to add 16 to 7 to get to 30. We wanted to add 23, so I do a conversion. All right, and so therefore the A term of a quadratic is rise over run squared as measured from the vertex. Okay, keep that in mind as we move forward with this video. All right. Now, my classic problem that I like to do earlier in a semester is Jim has a ball 3 feet high, kicks it, goes up to 67 feet, comes back down. All right, so what's that equation? Well, height as a function of time in this case is 67 to 3 is down 64. Notice I'm measuring from the vertex. I have to have a frame of reference, and the pattern emanates from here. Now, 0 to 2 means if I went back 2 units with a statement like t minus 2 that measures time elapsed, I'm going into the past. When I put a 0 in, I get -2, so I've gone back 2 seconds. I should go up 4, but I don't go up 4. I go down 64. And to get this trajectory, it's linear right now, it's quadratic, we can see that change of 0 minus 2 being canceled out of the problem to get what I want. Okay, and I have a frame of reference of 67. Well, that allows me to tell you when it hits the ground, because that's minus 16, t minus 2 squared plus 67, and I can see it from here that I hit the ground at 2 plus the square root of 67 feet. I'm changing by 67. And I'm dividing by minus 16. That's all here. I can see rise, minus 64, run squared. I can see it. So therefore, what I basically did was that, and you do the inverse operations, and you'll also find another root over here. All right, so everything's, and we multiply this out, and we get h of t equals minus 16t squared plus 64t plus 3, and you can start talking about initial conditions, initial force, gravity, so on and so forth. So it's a rich discussion, I hope. Not that I'm a physics teacher, and so I probably butcher it, but I get the ball rolling. We're using math to look at some issues from the real world. And just to tie in a couple of things, 2 was the most important value. And so if I do t minus 2 here, then I let t equal 2, then I have a 2 here, and a 2 minus 2 here, and I get a 4, minus 4, minus 4. And those are the linear components, the quadratic and the constant for here. So you add that up, you get 0. 0 squared is a minimum. You throw a negative in front of that, and then you get a maximum, so on and so forth. All right, so you drop a 2 in, you get 128 over here, so that's got to be minus 64 here, plus 3. And you can start to see that 2 to 1 ratio numerically. I just thought I'd throw that in there. But let's go back to that other problem and see if you, in 10 seconds or less, can tell me when this hits the ground. Now, you might have to play this video a few times. I suggest you do a couple minutes a day for 3 or 4 days in a row. Probably makes some sense, even if you haven't done the other work with the quadratic, the geometric work, the completing the square, putting things in graphing form, practice, 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 right? Allen Iverson, practice, right? All right, so when does it hit the ground? Well, as I'm looking at this, I'm saying, well, 75 inches, I got to come down 75 inches. I got to find the A term, which is rise over run squared. So I got the rise, which is really a negative rise. That squared, 0.1, well, I'm just going to leave it as 0.12 squared, right? And that's, I got to get the A term here. So I got to get the rise out of that, excuse me. So 75 minus 4. So I've come down 35 inches, and that took 0.12 squared, right? That's going to sit inside the square root. Got to get some space here. Then my frame of reference is 0.12. So that's when it's going to hit the ground. Now, it's not a very friendly number, but you can throw it in a calculator and get a nice decimal approximation. And I hope I didn't make any mistakes. And if I did, then I'll delete the video. I thought I actually made this one earlier this morning, still half asleep here, trying to wake up. And I just decided to do it again because I thought the other one was a little sloppy. The camera was not centered on what I was working on, so on and so forth. So I hope that understanding math takes patience, takes repetitive considerations, and if you don't get it the first time through, that's okay. Just look at it again. A minute here, a minute there. And over time, hopefully it will start to make some sense. Basically, what I did was put it in graphing form, h squared plus k. Maybe we could do that to finish this off. So you got t minus 0.12 squared plus 75. What am I doing? 75 down to 40 is minus 35. And there's your change. Your change should have been this 0.12 squared is where I should be. You cancel that because it's not where you are. So we change that to 0.12 squared, right? And that's what you get if you get a 0. Cancels, and minus 35 plus 75 nails that. And if you put 0.12, you get 75, nails that. It's a unique quadratic. And I believe that's when it hits the ground. I talked pretty quickly there. Play it again, Sam. All right, and I got that done before class starts. Yay. Have a good day.